Hi everybody, welcome back to the wonderful world of Mr. Duncan's class. We've got section 7.2 coming up, similar polygons. And I'm going to try to do it similar to the amount of time I did for the last video, maybe a little bit longer. Okay? And so the first thing we are going to do is say that two figures have the same shape, and two figures that have the same shape are similar if two conditions are met. One, corresponding angles are congruent. Notice the difference in words here. And corresponding sides are proportional. And the symbol we use for similar is this squiggly line here, the top of the congruent sign without the equals. Okay? You should remember this from middle school. Okay? So, as long as our angles of our figures are exactly the same and the sides are proportional, then we have similar figures. Let's see what this means in practice here. Okay? So we've got these two trapezoids, and it is saying that ABCD is similar to EFGH. Notice all of my pairs of angles are exactly the same. The D here and the H there are the same. E and A are the same. B and F are the same. And C and G are the same. As long as all of my angles are the same, I've got a good candidate here for similarity. Okay? And then what I'm going to do is check to make sure that the sides have corresponding length. So what that means is that I need to make a ratio. This side here has to be the same, or this side here compared to this side here, that is AB compared to EF, has to be the same, for instance, as CD compared to GH. And that has to be the same as BC compared to FG. And that has to be the same as AD compared to EH. Okay? So all of these ratios have to be equal, and as soon as they're equal, we know that we have similar figures. Okay? So let's do an example here. Decide whether the figures are similar, and if so, write a similarity statement. Okay? So we are going to walk through this in the next slide or two. So here are the two figures again. First of all, I look at my pairs of angles. I see that P and J are the same. I see that Q and K are the same, R and L are the same, S and M are the same, T and N are the same. So I have all of my angles congruent. Now all I need to do is check to make sure that the ratios of side lengths are the same. So I need to make a bunch of ratios. Let's move this down. Okay, so I get that PQ divided by JK, that's this side here, divided by this side here, is 3 divided by 4.5, which simplifies to 2/3. Okay, fine. Now what I'm going to do is I'm going to try another pair of sides. I'm going to say QR divided by KL. That's over here. And that gives me 6 divided by 9, or 2/3. Okay, looking pretty good so far because my ratios are turning out to be the same. Now let's do a couple more. RS divided by LM is 2/3. I don't even need to simplify that one. And I'm looking pretty good here. Okay, I've got two more to do. ST divided by MN. ST divided by MN is 4/6, or 2/3. And finally, PT divided by JN, or TP divided by NJ, gives me 5/7.5, which simplifies to 2/3. Okay? So I see that all of my sides have the same ratio. Okay? So we say that all of the corresponding sides are proportional, and then by definition, I can say that TSRQP is similar to NMLKJ. And let me just caution you right now, make sure, just like when we were talking about congruent figures, make sure that you put the corresponding parts in the same order. T corresponds to N, S corresponds to M, R corresponds to L, Q corresponds to K, and finally P corresponds to J. If you put them in the wrong order, your statement will not be correct. Okay? Let's go on. Let's decide whether these figures are similar. Well, first thing I can see is this one looks flipped, and because I have a smartboard, I am going to do something that you guys cannot necessarily do on your paper, but clearly neither can I on my smartboard. Okay, I'm going to flip this left and right, and what do you know, it now looks a little bit closer to the figure I have drawn, and if I even do that, now it looks a lot closer. Okay? And that will help me to figure out what sides correspond to what. Otherwise, you just kind of have to picture it in your head which sides correspond to which. But now you can see, hey, A and F correspond to each other. Okay? B and E correspond to each other. D and G correspond to each other. C and H correspond to each other. Great. Okay, now let's move on. I want to decide whether these are similar figures, and so first thing I'm going to say is what I just talked about. Make sure my corresponding sides are the same. Okay? And if you look here, you see that C, which corresponded to, let's do it in order that they did it. A, which corresponded to F, I've got the 2 marks there, which tell me that those are equal. Okay? B, which corresponded to E, are both 74 degrees. C, which corresponded to H, both have the single angle mark, and D, which corresponded to G, both have the same measure of degrees. So we are good on that, and we just have to figure out whether or not these two figures have sides that are proportional. Okay? And it's kind of a mind game with yourself. You have to kind of think about, because they're not in the same orientation, you kind of have to flip them around and make sure that you're comparing the right sides. So the first side we compare is DC and GH. When we divide those, we get 1 over 3. Okay, so 1/3 is the one we're going to be comparing to. Next thing we do is AB over FE. Okay, we get 1.5 divided by 4.5 does give me 1/3. And so far I'm looking pretty. Next thing, BC over EH. 2 over 6 simplifies to 1/3. Great. Amazing. I'm tempted right now to say, hey, these two figures are definitely similar. But I can't stop until I can't say that they're similar until I keep checking all of the ratios. So the last one, AD divided by FG, 2.5 to 7 does not simplify to 1 over 3. These are not similar figures the way that I have drawn them, because not all of the sides are proportional. And that's what you have to do. Okay? So this one is for you to answer, as is that one, and this one's for us. Okay? Let's solve for the variables. Let's see if I have some slides. Yeah, I do. Okay. We know that these, I'm sorry, what does it say? Let's go back. It tells me that these two shapes are similar to each other. So I know that when they are similar, their angles have to be exactly the same. So I know that this one, which I can barely see, so I am going to make it a little bit bigger. I was going to try to make it a little bit bigger. Never mind. Okay, there we go. 92 degrees. That's the one I couldn't see. I know that 92 and M, so that was H. H and M are corresponding to each other, the angles. So I know that those must be the same, because in similar figures, angles have to be congruent to each other. Slight smartboard technical issues. Okay, so I know that H and F, H and M must be congruent to each other, and F and Q must be congruent to each other. Okay, so I automatically know that H is 92 degrees, so M must be 92 degrees. And I know that f is 5y and q is 125, so f, or x, or y rather, must be 125 divided by 5. And so I get that y is 25, x is 92. Great. Doing well so far. And then what I know is that the proportions must be the same. I think that's on the next slide. Yep. I know that the proportions must be the same. So I've got them all listed here. dE must be over NP, must be the same as EF over PQ, must be the same as, and we can go around and around. Okay? And so I will start making these ratios. And as soon as I get one that's both numbers, I know what every one of them has to be. So what I do is I do ED, or dE over NP, and I get 4 over 2. Once I know that these are 4 over 2, I know that they all must be 4 over 2, or similar to it. So 4 over 2 must equal 3 over W. This is one I need to solve. And that must equal 6 over Z. Okay? So if that is true, then I have dE over NP equals EF over PQ. So 4 over 2 equals 3 over W. And I'm going to solve this by cross products. 6 is equal to 4W. Divide both sides by 4. Divide by 4. W is equal to, simplify by dividing both sides by 2, is equal to 3 over 2. Okay? And then over here again, I have 4 over 2 equals 6 over Z. Cross products. Cross products. 12 equals 4 times Z. So clearly Z equals 3. And I am done with my problem. Excellent. Let's try this one. We know that these two are similar to each other, so let's solve for the variables. Once again, I'm going to play with my smartboard to get these to look exactly the same, or close to it anyway, so I can think about what is, so I can think about what is similar. And there's one other thing I want to do. I want to flip this up, down. Now they look the same. Great. So I know what is corresponding to each other. And again, when you don't have a smartboard, you just kind of have to do this in your head. Okay? But we know that we've got how many variables here? We've got x, we've got y, and we've got z and w. Okay? Well, this one's a 90-degree angle, so I know that 6w must be a 90-degree angle. So 6w equals 90. W must equal, 90 divided by 6 must equal 15. W equals 15. Great. Done with one of them. That was easy. Okay, great. Now let's do the next. W is crossed off. Let's see if there are any other angles. Sure. 4x corresponds to 112, and so I know they must be equal. Divide by 4. Divide by 4. I've got x equals 28. Excellent. That was easy. What's next? I know that my sides must be corresponding to each other, and I look for sides that have both numbers, so I can get one of these to be a fraction. So I know that QR over JM is equal to 5 over 2. But I know that these figures are similar, so I know this 5 over 2 must be equal to every other ratio of side lengths, and so I look for one more. 5 over 2 must equal PQ over JK. Okay? So I have that 5 over 2 equals PQ over JK. Okay? PQ is 10. JK is Z. So I have 5 over 2 equals 10 over Z. I can do cross products again, or I can just see that this one's easy. Times 2 there, so this one must be times 2. You can do the same thing with cross products. You'll get the same answer. Z equals 4. Okay? And now I am just about done. Let's give myself a little more space. What's the last one? Y. Well, I'm going to go back to my ratio that I found here. 5/2 is the ratio of any side from this shape right here to any side from this shape right here, as long as they are corresponding sides. Okay? So I have PS over, is that KL? Yep. KL equals y over 2.4. And I know that this has to equal 5/2. So here's my proportion I'm going to work with. Now I will do cross products because I can't find any tricks real quickly in my head. 5 times 2.4 is going to be 12 equals 2y. And so I can easily see y equals 6. Let's just make sure I didn't make any quick, silly mistakes. There are the 4 answers I'm supposed to have. Let's pull out. Okay, w is supposed to equal 15. Yes. X is supposed to equal 28. Cool. Y is supposed to equal 6. Z is supposed to equal 4. We wrong. Let's move on. Okay, that one's for you. Theorem 6.1. If two polygons are similar, then the ratio of their perimeters is equal to the ratio of their corresponding side lengths. Okay? What does that mean? Well, it's just like what we just did, only slightly different. We know that if these two figures are similar, then the perimeter of ABCD, that's all of these sides added up, is divided by the perimeter of WZYX, all of these sides added up. They must equal the same ratio of one of these sides, let's say that one, to one of those sides that is corresponding to it, that one. Okay? This might be a little bit complicated. You can pause it, think about it for a second, or we can do a problem, which I prefer. Okay? We know that these two figures, the scale factor, I'm sorry, let me just stop for a second. We know that ABCDE is similar to PQRST. Find the scale factor that is the factor between AB and, say, RQ, and find the perimeter of each polygon. Okay? So what our theorem just told us is that the ratio of the side lengths must be the same as the ratio of the perimeters. So first thing I'm going to do is I'm going to label all of the information I have in each of these figures. These two are the same, so I know that this must be 8. These two are the same, so I know this one must be 4. And what do you know? I have all the sides of A, B, C, D, E. I'm going to do the same thing over here as much as I can, but the only other one I can fill out is that 3 there. Now what I need to do, it tells me to find the scale factor and to find the perimeter of each polygon. Here's the trick though. There is nothing more I need to do with this polygon, this pentagon, in order to find the perimeter of it because of the theorem we just talked about. Okay? So the only thing I have to do is find the scale factor. So I find two sides that have the same corresponding, that are corresponding sides. So AE over RS will give me my scale factor. AE divided by RS is 4/3. So the scale factor of one of these to the other is 4 to 3. Great, I found my scale factor. Now I know that this must equal the perimeter of ABCDE over the perimeter of the other guy, R, S, T, Q, P. Those are not in the right order, but for perimeter it doesn't matter so much. Okay? 4/3 must equal the ratio of the perimeters. Well, I know the perimeter of this guy over here. The perimeter is 8 plus 8 plus 4 plus 4 plus 6. There's 10. There's 16, so that's 26 together plus 4 is 30. Okay? So 4/3 must equal 30 over the perimeter of R, S, T, Q, P. Well, I can do a lot of things here, but what I'm going to do is cross multiply. I get 3 times 30 equals 4 times perimeter of the other guy. Okay? And that is 90 equals 4 times the perimeter. Divide by 4. Divide by 4. 45 divided by 2. I actually need a calculator for that one. You know what? Never mind. I'm just going to leave it as 45 over 2. The perimeter of the second guy equals 45 over 2, or 22 and a half, but we'll do it as 45 over 2. That was the perimeter of the smaller. The perimeter of the larger, again, was 30. And we're done. Okay, this is your turn. You'll do this scale factor question, and then we're going to be done. That's all for me. I'm going to San Fran. See you guys later.